Question 1. Well, here we're asked to find the gradient, so we're going to have to differentiate. Multiply by the power, reduce the power by 1. You're given information that x equals 2, so put 2 instead of x, and you find the gradient at 2 is 8. This one here you're given y dash, so we have to anti-differentiate. Anti-differentiate, write out the equation as it is, and change the 2 to a 3, divide by the new power, make the x appear by the number, add the constant. If you do one term at a time, you should get it right. Now put the x value in and the y value in. We find that x is -1. You work out what that is. C is -1. And then write out your equation again, and you have another achieved mark. For this one here, we want the tangent. That's the equation of the tangent. So we want to find the gradient first. To find the gradient, you need to differentiate. Multiply by the power, reduce the power by 1. You're given the point -1. That's your x value. So replace x with -1. You've got what y dash is. That is the gradient. Now put that into the gradient equation and use the point -1 and 1 to work out what c is. And c equals -7. Now write out your equation for the gradient and you have a merit question. For this one here, it looks complicated. Let's do it one bit at a time. You anti-differentiate to go from g triple x to g double x. So we have to add 1 to the power and divide by the new power. A number goes to an x at a constant. We have the information of 2 and 2, so you put the 2's in there and you can work out what the c value is, write out the g double x again. So we've done the first bit to find g double x. Now we have to find g dash. So what we do to find g dash x is we copy it out, add 1 to the power, divide by the new power, make the x and the c appear, simplify, put the 2 in there, and you can work out what the c value is. Write out your gx equation. Now notice I'm using different colours for these. Each equation is different. Now we want to find the g equation, the original equation, so we're going to have to anti-differentiate again, copy it out, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, simplify, make your x and your c appear, then put the 0 and 2 in there, x is 0, c equals 2, write out your equation again. Oh, look at that, that's for excellence. It's not really hard, just got to do it several times. For this one here, we want to find the maximum area of a rectangle. Well, if the base is x, the height must be 9 minus 2x squared, so the area is base times height. Multiply that out. Once you've got that, you're on your way to excellence, because you should know you want the maximum, differentiate it, make it equal 0, solve for x, change side, change sign, square root your answer, your plus or negative root of 1.5. You're not going to have a negative value for the area. So x equals 1.225. We can ignore the negative and work out the area by multiplication and substitution, 7.35 units squared. You could double differentiate to find that it is a negative value to prove that it is a maximum. We're done.